Welcome to our tutorial, King David Academy Tutorial, Senior Physics. And under this, we have already covered pressure in solids, and we looked at maximum and minimum pressure. That is in the previous tutorial. Then we have looked at the applications. So today, in this tutorial, we are looking at. In this tutorial, we are going to look at pressure in fluids. Pressure in fluids. Pressure in fluids. And under this, of course, we know fluids. We very well know that fluids are liquids and gases. Though quite often people mistake it to only apply to liquids, that is wrong. It is both liquids and gases. Those two are collectively termed as fluids. So, the first that we are looking at in this tutorial is pressure in liquids. Pressure in liquids. That's the first thing that we are going to look at. We're first going to look at pressure in solids. So under this, we need to know the formula for pressure in solids. We need to come up with a formula. We have to do the numerical work, and we need to look at the applications in a later tutorial, at a later time. And we look at the factors that affect pressure in solids. Then we look at this is the factors that affect pressure in liquids, rather in liquids. We shall also look at gases, but not now. Then we should as well look at the properties of pressure. Properties of pressure in liquids. Properties of pressure in liquids. So these are some of the things that we are going to look at in liquids. So if I have a container that is having my liquid, this container is of cross-sectional area. This is the liquid, which can be water, alcohol, mercury, paraffin, oil, milk, urine, blood, name them, the different liquids. So this is the cross-sectional area. Cross-sectional area A, and this is the height of our liquid, and which we can call the depth of the liquid. Of course, that is the entire container. That is our container. This is the liquid. This is the liquid of density rho. The density of the liquid is rho. So now what we need to know is we are going to start with, first of all, getting the weight or the mass. We start with getting the mass of this And to get the mass, we remember very well this triangle. This is mass, this is density, and this is volume. So we remember that mass is given by density times volume. Mass is density times volume. So in this case, we shall first of all get the volume of that liquid. Volume of the liquid. Volume of the liquid is got by area, cross-section area times the height, and which gives us A H. In this case, that is the volume. That is this is a cylindrical kind of container. So the volume of this entire liquid is got by the cross-sectional area, this A times the length, the height of that liquid inside the container. So that is the volume of the container. After getting the volume of the container, we need to get the mass of the liquid inside. Mass of the liquid inside is got by volume times density. Volume is mass is volume times density. Where the volume is AH times the density, which I have already given to you as rho. So that is all about that. And so we have just said mass of the liquid. From the mass of the liquid is volume times density, and the volume is AH times rho. So we are at that point, and then let's get to the weight of the liquid. Weight of the liquid is equal to mass times acceleration due to gravity. So this reduces to AH rho G. So that is the weight, which is the same as the force. That is the weight or the force exerted by the liquid on the container. Then, if that is the force, we go now to our formula for pressure. Pressure is equal to force over area. And the force is given by rho G divided by area A, where this S will cancel and we remain with H rho G. So in conclusion, pressure in liquids is given by this whole expression, rho GH. You can arrange those letters in any way that you prefer. So we can respect the formula by putting it in a box or in a rectangle. That is the formula. Rho is the density of the liquid. G is the acceleration due to gravity, a constant. H is the height of the liquid or the depth of the liquid. You can call it that as well. So that is the formula that we are going to always use. I repeat, rho is the density, H is the depth or the height of the liquid, and G is the acceleration due to the force of gravity. So that's what we're going to use to do some examples that are going to come in the next. So this is our example number one. We have just looked at the formula for pressure in liquids. So we summarize what we have. The liquid here is water. They are talking about it. They have given us, of course, we have not seen any other swimming pool of any other liquid except water. Maybe if you can try out one, you can try out a swimming pool of alcohol, or a swimming pool of water, or a swimming pool of any other liquid. But we all know that the liquid inside a pool normally is water for its own reasons that we all know. Otherwise, if you dive in a swimming pool of alcohol, then the result is always known before you even dive. So Let us summarize. G is a constant. This one should always be in your brain, in your medulla. The density of water is given 1,000 kilograms per meter cubed, and the depth of this swimming pool is so the height is 1,000 centimeters. So you realize that this is a strange unit. It is strange, and we should do the needful to, we should do the needful. So we know 1 m, 1 meter, not 1 million, but 1 meter. 1 meter is 100 centimeters. So if you have 1,000 centimeters, no, it is obvious. So 1 centimeter is 1 out of 100 meters, and therefore 100 centimeters are simply 1 out of 100 times 1,000. And the mathematicians will tell me very fast that this is 10 meters. So in 1,000 centimeters, we have 10 meters. So let's go ahead and now put down the formula for pressure. For pressure is given by rho H. Rho is 1,000 times G is 10 times the height is 10, and all this is expected to be in pascals. So this gives you 100,000 per pascals. And that is your answer, or that is our answer for this question. So let me give you one more, and that will be the end of our tutorial. But take note of all the work that I've done, the adjustment, the conversions of the unit to the suitable SI. Okay, so from the previous number that we have looked at, let's look at the second. And the question reads here: the tank below contains mercury and water. Find the total pressure experienced at the bottom of the tank. This information is important. Density of mercury is that, and density of water is that. So this is our figure. The water is here, mercury is here. Now, members, it could have as well come without them labeling for you the given layer, the different layers. We must know that the density of mercury is far, far, far bigger than the density of water. And from the fact that the denser objects sink while the less dense ones float, we expect mercury to sink and water to float. So expect that the question of the same can appear without them labeling for you this. Expecting that you as a physicist and a scientist should figure out how the density affects floating and sinking, flotation and sinking. So that is what we need to know about. Briefly, we should always remember to convert. So we are starting to answer. 2 centimeters is the same as 2 divided by 100 meters, which is 0.02 meters, and 3 centimeters is equal to 3 divided by 100 meters, which is 0.03 meters. So these are important values for us as we kickstart the solution. So we have just converted our 2 centimeters to meters, which is the 2 divided by 100, and we've got 0.02 meters. Then the same applies to 3 centimeters, 3 out of 100, which is 0.03 meters. We have looked at all that. So we go to the pressure exerted, first of all, by water. Will be pressure exerted by water will be equal to the density of water, G, and the height of water. Density of water is 1,000, G is 10, height of water is 0.02. So this gives us, compute it, and this is 10,000. So this is 200 pascals. Assuming that I'm not wrong, that is 200 pascals. So we go to the pressure. Exerted by mercury. pressure exerted by mercury is the density of mercury, G, times the height of mercury. The density of mercury is 13,600 times 10 times the height of mercury is 0.03. What do you get there? What do you get there? So it is giving us 4,080 pascals. Those will be the calculators. You can confirm that answer. So these are the two pressures, but they wanted the total pressure. So total pressure, you can use this side. So total pressure, is the pressure by mercury plus the pressure due to water, 4080 pascals plus 200 pascals. So the answer is 4280 pascals. And that marks the end of our lesson and our tutorial for today. See you in the next tutorial, and be ready for many questions and assignments. Bye.